Good afternoon. I would like to welcome you for another session in the introduction to robotics. Today we are going to discuss about the topic of industrial robots and applications. So myself, Sambasam, Assistant Professor, Department of Mechatronics Engineering, SNS College of Technology. So normally we have discussed about what is the introduction and what are the robotics importance and what are the sensors used and everything I have discussed in the previous video. Now we are going to discuss about the industrial applications of robotics. So what are these industrial robot applications? That is robot work cell design control, safety measures in robots, robot cell layouts, multiple robots and multiple machine interface, and robot cycle analysis. These are the various topics comes under the industrial robots and application unit. So and one of the important feature is the industrial applications of robots. So based on that, we have designed three work cell layers. The first one is robot center work cell, an inline robot work cell, and another one is mobile work cell. So what do you mean by robot centered work cell? So normally robot is placed in the center of the conveyor where it is able to perform in X and Y and Z directions. So it is an example of the pick and place which is shown in the figure where the robot has been placed in near the conveyor where it is in fixed position. The conveyor moves from raw material to end product. This is like a pick and place robots. So this is similar to the robot is fixed as center and which makes the high utilization of the robot, and also it is especially used as a conveyor or part feeders, especially for method of work part delivery. And instead of a single robot service, one or more product machines can be produced. And a cell layout. So as I said that the robot is fixed in the two pictures. The robot is fixed in the material of machining 1 and machining 2, where incoming materials and outgoing materials are done. Where the robot tends to move takes place in the incoming material and the machine interfaces in machine 1. Then the robot takes particle into the machine 2. Then the output product has been sent to the conveyor. It is similarly the three machining centers have been done where the conveyor also plays in the form of Q and Y, input and output. So once the robot takes the workpiece from input, takes it to the first machine center, then it has come into the next machine center, then it travels third, and finally it is released in the workpiece. So the entire process has been by using a single robot. This is how the cell layout has been identified, and they are kept for machining purposes. So what is the purpose of this thing is this is the one of the key features especially used in the modern industries where the multiple process has been carried out in a single form. So the cell layout has been important few features where the cell layouts becomes important to reduce the human error, and also the time consumption for multiple tasks has been reduced by using this kind of layout. This is the important feature as used in the industrial purpose. So as I said, the example for this kind of cell layout is where the ongoing material has been taken for especially for using in high manufacturing of industries like pump industries, where the raw material has been taken through the incoming conveyor. So or where the raw piece can be taken from the materials. Once the raw piece has been taken, then it is traveled to a machining 1 where the outer layers of facings or turning operation, drilling operations, or something which is related to make a whole parts are be taken into consideration in the machining parts, where all part machining has been carried out in the machining 1 sector. Once it has been done, then it is a surface finish, right? Or it may be a surface coating, or it may be a painting. That can be done by using in the machining 2, where the particle has been traveled from machining 1 to machine 2 by using of the robot arm. So once they have been done it through that in the second spot, then it is taken into a second machining part where it has been covered all the surface finishes, outgoing process materials or quality finish, surface finish, everything has been done into. Once it has been, again the robot goes into the machining center and takes the workpiece and then deliver into an outgoing conveyor where the end product has been delivered through a conveyor and the outgoing space. So finally this cell layout makes an entire process to complete the machining process. This layout makes a most important factor where the current industrial application requires a more number of products. So it reduces manpower. It also produces an accuracy part. Instead of single robot, multiple robots, the single robot plays a variety of roles where it can able to achieve the constant output products, which results in the high productivity rate. So the companies provides this kind of layouts. So this is the one of the layout. In the next class, we are going to discover the next two layers which is important for the industrial purpose. And thank you for watching. Let's see then another we will see in the next session.